Okay, hello everybody, welcome. Does anybody have any questions about, because first of all, we don't have class during the quarter break. So that is, I think, this. That would mean we don't have a class on the 30th. Okay, there's no class on the 30th. Okay, so we'll have a class next week, and then we'll have a class on the 6th of June. Will be our next class. Okay? However, it looks like in terms of homework, there is some homework due on the 30th, so make sure that you do that. Okay? And there's some due on the 9th as well. And it's possible I might add a little homework before the end of the quarter break, so pay attention to that. So just to remind you that if you go to here in notifications, you can set up to be notified. Remind me by email when an assignment is due, so you can be reminded 48 hours ahead or 30 hours ahead, whatever. And notify me by email when my instructor changes a due date. So you can set that up. Okay, so you might want to do that just in case I add some assignments. Okay? And okay. So does anybody have any questions about anything? Sorry? The midterm, let's check the syllabus. Let's go to here. So let's take this out. Look here. So it says on the 7th class, but it's not going to be on the 7th class, because the 7th class is probably next week. We're not going to have it then. So we're going to have an exam. Okay, let's set the date now. So we'll have it on the 13th. Okay? So we'll have the exam on the 13th. It won't take the entire class. Take maybe 40 minutes. Okay? Probably anywhere from 13 to 20 problems. And the problems will come from the homework. Okay? So we just review the homework and make sure you can do the homework, and then the problems will be the same. Okay? Anybody have a question about this? And it'll probably be done in the computer room. Okay, so we'll do it online. All right? I might do it a paper test actually, but we'll see. Okay. Any other questions? Okay. And I forgot one more thing. And that is, for anybody whose score is less than 85, you can get extra credit by going to the tutoring center called the AMC, which is in the library on the first floor. And if you don't know how to use the system there, just walk over there and, like how to make a reservation and so on. You can do it online, but you can do it there, and they can explain to you how to do it online. And also you're allowed to just walk in and get help, but that's dependent on whether there's nobody else who's there. So you can also make a reservation. So you just walk over there and ask them how to do it. They'll explain it to you. Okay? So anyway, you can get extra credit if your percentage is lower than 85%, and you have to give proof that you actually went there. You have to give that proof to me, so they will sign something. So you just bring that to me, and that will be the proof that you went there. And the you get half a percentage on your final grade for each session that you attend. But this is only available to people whose grade is less than 85. So if you already have, and you can only increase your score up to 85% by doing that. So otherwise it wouldn't be fair to the people who are doing better than that. Okay. So, but you, if you're in that position, you can go and this is to encourage you to use that center and also to encourage the center to be used. So we want to encourage people to be there, to use it. Okay, so anyway, if you want to do that, please go ahead. Just don't forget to get a slip that they sign, and then you can get the credit from me. Okay? Any questions about that? Okay. All right. Anybody have any other questions? Problems? Yes, sir.
I missed one homework.
Sorry?
I missed one homework.
You missed one homework.
One assignment.
One assignment. Okay.
Uh,
Did you try to get an extension?
I was too late.
Sorry?
I was too late
You were too late even to get the extension.
to apply for the extension because it wasn't there.
Because it wasn't what?
It wasn't there.
What wasn't there?
The assignment.
Oh, really? Well, for example, which assignment did you miss?
The more linear.
Well, hold on, let me get the past assignments here. So click here, past assignments. Maybe you didn't see this, right?
Oh,
Okay, so this shows the past assignment. So which one did you miss?
the last one.
This is a more simple interest problem? All right, I think you can still get access to this. Okay? Okay. So maybe you didn't see that. Yeah, they put it down here. So this only shows you, but you better hurry because there is a short window when you can do it. Anybody else? Any other questions? Okay. Okay. So let's look at some homework. That's due. Next homework is due here, May 30th. Okay, so there are 13 problems. And the first one is this one. So I think we haven't talked about that notation up to now, right? Right? Did we talk about this before? No. Okay, so just ignore this for the time being, and just look at this function. Okay, so this is a ratio, right? Obviously a ratio. And we can say that the top one is a quadratic function. We can say that the bottom one is a linear function. We can also say that they're both examples of polynomials. This is a polynomial, and this is also a polynomial. Right? Does everyone agree with that terminology? Polynomial means like you can have any degree here, 2, 3, 4, 5, anything. Okay, and you can have a bunch of terms. Okay, so that's called a polynomial. So, okay, so again, forget about this symbol, just ignore it. So just think about this function. So, if I asked you, one thing that we want to do with functions is graph them. Right? That's one thing that we want to do. So, if I asked you, what do you think the graph of this would look like? Does anybody have anything that you might want be tempted to say about it? No, we don't have any idea, maybe, right? If I just gave you this function, I think you wouldn't have any problem telling me what that looks like, right? That would be just a straight line. And I think if I gave you just this function, you wouldn't have any problem telling me what that looks like either. But this one, together, maybe we don't really know what it looks like, right? Okay. But one thing that when you want to graph a function, there are a couple different things that we tend to do at the beginning. And one of them is ask what it looks like for very large values of x. So when x is 1,000,000, 1,billion, 1,000,000,000,000, and so on. So can we make any kind of statement about that by looking at, right? Is there anything that we can say about it? So the point here is that the exponent, the power in the numerator, is bigger than the exponent in the denominator. Okay? That's true, right? The exponent here is 2, the exponent here is 1. And that turns out to tell us basically what's going to happen for large x. So for large x, for example, let's put in 1,000 here. What do you get? 1,000 squared is, so 1,000 has 3 zeros, so the square is going to have how many zeros? 6 zeros, right? That's what number is that? Million, right? That's 1,000,000, right? So the top is going to be 1,000,000, or actually 1,000,000 plus 4, right? And the bottom is going to be what? Just 1,000 or 1,001, right? So the top is going to be much bigger. And that was for 1,000. If it's 10,000, it's going to be worse, right? Because the numerator is going to be what in that case? 10,000 has 4 zeros. So 10,000 squared has 8 zeros, so that's 100,000,000, right? The top is 100,000,000 and the bottom is 10,000. So if you do cancellation, you end up with what? Four zeros on the top, right? So it's 10,000 times bigger than the bottom, right? So you can see from this kind of thinking that as x gets big, this thing gets bigger, okay? Now, suppose it was reversed. Suppose the top had just the power of 1, and the bottom had just the power of, had the power of 2. Then what's going to happen? Suppose that we had the inverse here. So this was only power 1, and this was power 2. Well, what would happen then for large x? So if you have a square, let's say we put in, what did we say? We put in 1,000. So the bottom would become 1,000,000. And the top would be what? 1,000. So that's a difference of a factor of 3, right? It's like 10 to the third, right? So that's like 1 over 1,000. What kind of number is that? Is that a big number or a small number? 1 over 1,000 is a tiny number, right? So that means that this thing is close to 0. So the graph is close to 0, right? If we reverse this, right? So if I put in 10,000, it's going to be what? Even closer to 0, right? So the larger, in that case, the larger the x, the closer this would get to 0. So that means that, let me just write that. So suppose we had this one, x squared on the bottom, let's say that, and x plus 10 on the top. So what's going to happen? For large x, we just said it's going to be close to 0, right? So let's put large x over here. So I'm just saying that somehow it's going to get smaller and smaller. Okay? Whereas if we reversed it, if we had x squared plus 1 over x plus 10, then we said, no, it's going to get bigger and bigger. Okay? So this is one thing we want to ask when we look at a function. What happens for large x? Okay? That's just one thing that you should ask. Or if you don't want to do that, you have to do it for this course, or you have to do it for these problems in the book. Okay? That's what they want us to do. Okay, so that's one thing. So for this one, we would say for large x, the function gets bigger and bigger. Right? Okay, so now so another thing that we ask is there any place where the function is not defined? That's just another question that we need to usually ask in the homework problems. So what about this one? Is there any place that it's not defined? So it's a fraction, right? So fractions are not defined when their denominator is 0, right? So we could say, is there any place where the denominator is 0? And the answer is obviously yes. Right? Where? When x is -1. Okay? So therefore, whatever we draw, I don't know what it's going to look like. It doesn't look like this. It looks like this somehow. But I don't know what it's going to look like, right? We don't know yet. But we do know that at -1, it's what? It's not defined there. Sorry. At -1, it's not defined. So whatever it looks like, it doesn't quite look like this. Because here we have to put what? A circle there, just to say that's just a notation to say that it's not defined there. Okay, so that's just our way of graphically saying it's not defined there. Okay? So that's the other thing that we need to do. Okay? Anybody have any question about that? Okay, now let me take a picture of a function. Let's suppose I have a function like this. And let's call it f. And let me do this. So I want to ask you, is that a function? So just to review, suppose I gave you that graph. Would that be a function? No. Why not? Because for a function, we have to have, if you have a here, if I ask you what, let's say this height is b, and let's say this height is c. If I ask you what is f of a, what are you going to tell me? What's f of a means? What's the height of the curve at when x equals a? So what are you going to tell me? What would you say is the height? What would you say is the height? Well, the problem is that there are two heights, right? The height is b, and the height is c. You'd say, f of a equals b, and you'd also say f of a equals c, but we don't want to do that. So we don't call this a function because we don't want to have to say that. Okay, I mean, it is true in this case that f of a is equal to b and f of a is equal to c, but f is not called a function in this case. Okay, so it's called a relation. So it's good to have that we have, we can work with these things because these things do exist. We might want to use something like this, but it's not called a function. It's just called a relation. And so relations are kind of more general than functions. So every function is a relation, but relations aren't necessarily functions. So this is a relation, but it's not a function. Okay? So anyway, this is not a function because why? Because you can, the other way to say it is you can draw a vertical line and and cut it twice. Because that means if you cut it if a vertical line cuts it twice, it means that when you put in this value, you get two different outputs. You don't want that. Not for a function. So that's the idea of a function. Okay, so this is not a function. But my question was, is this a function? So you can think about it in terms of the vertical line test. So is it a function or not? Yes, it is, right? Why? Because you can't draw a vertical line anywhere and cut it twice. But you might say, wait, how about here? Right? How about there? But no, the whole point of this circle is to say what? That that's not the value there. Right? That's the point of drawing that circle there, to say that. So, and the whole point of drawing this dot here is to say what? That is the value for f. So if I ask you what is the, f of x1, you'd say, oh, I just put in x1 and I go over here and that's the answer. And if I say, what is x2, you say, oh, I just put it here and over here and that's the answer. Right? And if I ask you, what is f of a, you would say what? You just tell me the height there, which is what? C. So f of a equals C. Does everyone agree with that? Okay? All right. Now we need to talk about this idea, this thing called the limit. Okay? The limit. So the limit is used for helping to work with this kind of function.